Okay, let's start math class. Welcome back, 10B. And before we begins with the quizzes, of course, let's pray first. And hopefully you can learn many things in this meeting and you can be attentive and can digest what's being delivered. So yeah, I will ask for now. Vanessa, please.
Friends, let's pray. Dear God, thank you for today. Now to start the math class, please bless us so we can understand the lesson and also do the quiz as well. In Jesus' name we pray. Amen.
Amen. Okay, so let's start with the quizzes. I will share the link on the chat and it will be a quick one. So it's only 5 minutes. I want you to focus. The material will cover exponential and logarithm from the previous meeting. Okay, please wait. Yeah, it's okay. So I think, yeah, I think we have all. Now let's start. I wish you good luck. 5 minutes starts from now. 2 more minutes. One more minute. Twenty more seconds. Ten more seconds. 3, 2, 1. Okay, time's up. Okay. So, any question regarding yesterday's material or the mini quiz or something that you want to confirm? Any question? You're good? No problem then. Okay. So before I start, let me just post this to YouTube. So whenever you ask, I don't have to upload it myself. Today we will learn new things. I will specifically discuss about the first part of your homework. Okay. So tomorrow I will share a video to discuss the second part. I think the second part is much easier for you to understand by reading the textbook. The first part, it's kind of confusing, so that's why I need time to explain it. So now, yeah, be careful, be careful. The answer on the quizzes is keep randomized, so you need to be sure it's true or false on the right position, okay? And yeah, there are 3 big points here, okay? According to the textbook, I refer to the examples. Actually, when the textbook provides you examples, it means it is very important. So let me just divide it into 3 parts in this for today, okay? I want you to bear with it because, again, before we go to the properties, I remind you, whenever you are not strong enough with the definition, properties will be a hell for you. Okay, so you need to be firm first with the definition. So if I say that I'm still discussing about logarithm with 10 as its base. Okay, so we're still dealing with 10. Based on yesterday definition, 10 to the power of a equals c. So you can transform into logarithm statement, which is a, the exponent, equals log of C, right? So, I want you to learn about how to translation, okay? Not translate, translation. Okay, whenever I am asking you about log 55, what is log 55? It means I'm asking you 10 to the power of what? So you can have 55. That is log 55 if I translate it into daily language. Okay, so again, if I ask log 100 equals what? It means I am asking you 10 to the power of what to be equal to 100. Okay, so in the end, you know, for the second part, without calculator, I can directly know that the answer is 2. Since 10 to the 10 square is 100, so it's 2. But for the first question, of course, I cannot handle it by my mental arithmetic, right? It's beyond us. Okay, although you can do it, of course, if you are quite brilliant, very brilliant. So I want you to learn how to translate it. So now my next question is, let me ask Crystal, log 10 cube equals to what? So what is the translation for this one? Crystal, can you practice yourself?
10 in the power of something equals 10 to the power of 3.
Good. Now, can you find something?
Is it 3?
Yeah. So by this definition, log 10 cube will be 3 because we use the definition. So in the end, the conclusion, for example, log 10 to the power of negative 1.23 equals what? Mr. Sadis, enggak, gampang. Jawabannya adalah, the answer, I don't have to, the answer is negative 1.23. That's all, right? Because we are asking you 10 to the power of what to becomes this one, right? So the answer is the exponent itself. Okay, so the 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 conclusion is log of 10 to the power of a will be a. Okay, and the interesting part is a will be all real number. So all real numbers. It can be negative, it can be rational, it can be 0. The answer will be the exponent itself. Any question? You're good? Okay, okay. The last thing about the first part that I want to remind you is this, okay? First, log of A, it is 1 unit, right? 1 unit. So you cannot separate them. Therefore, if I'm saying log A square, you have to be sure that 2 is the exponent of A, not log A. So 2 belongs to A only, not the whole thing. So when I'm speaking about log 10 to the power of 5, it is equal to 5 because 5 is the exponent of 10, not the exponent of the whole thing. So if I'm speaking about the whole thing, I am supposed to do this. If I'm saying log A times log A times log A, it is log A square, but I have to do parentheses. So it will be clear that the square belongs to the whole thing, not belongs only for A, not belongs to the A. I want you to be careful in writing and in interpreting. Yeah. Okay, any question? Be careful with how do you write when you meant log A times log A, you have to do this, or usually we accept also this one. So the square is in the middle and like this. Yeah, we accept also. But again, do not do this. Okay, this is the wrong one. Okay, log A square. Oh, I know about the distributivity thing. So it is log square A square. No, don't do that. Log A is 1 unit. So you cannot distribute since they are not separated. Okay, so this is wrong. I will correct this. Okay, that is from the first part that I want you to get firm with it. Okay, the definition of log 5, log 6. So we are speaking about the exponent. What is 10 to the power of something to become that number? So last chance. Any question or affirmation or confirmation? Anything from you? You're good? Okay. Okay. If you're good. So let me go to the second one. I remind you, we have three big things here now. Let me clear all of the, okay. Number two. Number two, if I have A equals to 5, I will use the equality axiom. So it means if I do something on the left, I have to do the same thing to the right? So that is equation, uh, how it works about equation. So whenever I put log to the left, log A, it will be equal to log 5. That's all. Okay. So whenever you have the situation, for example, x equals y, it means log of x must be equal to log of y. That is number two. But from number two, I want to relate with number one. I want to show you that whenever we accept the properties or axioms in math, it's because they support each other. They are not conflicting to one another. That's why I want to prove you that the second definition, this one, will be consistent with the first. Okay. Okay. Let me just give you an example. So I'm just proving here. I want you to understand that it is whenever you have, so here's the thing, like before when we're dealing with exponents, Mr. I think I have already done it right, but I have different answer. Well, it must be wrong. There must be wrong in the middle. Must be. We in math we accept all the properties because it is consistent. So it will support each other. It's not conflicting. So let me show you example. Example 10 to the power of x equals to 7, right? And by definition, the first one, if log to the power of x equals 7, it means x equals to log 7, right? Okay, let me use the second definition, this one. Can we have the same outcome? If I use log for both sides, I have log 10 of x, 10 to the power of x, sorry, equals log 7, right? And from the previous, if we have log 10 of x, it will be the same with x, right? Let me remind you, log 10 of to the power of 5, it will be equals to 5. Log 10 to the power of 3 will be equals to 3. Log 10 to the power of x will be equals to x. So x equals to log 7. So again, we can be certain that this is a correct definition. So we can use the logarithm on both sides. Okay. Any questions? So I'm just showing you. I hope it's not confusing. I'm just showing you the consistency between the first definition and the second definition. Okay. Any question? We're good? Okay, and this is the last part. The last part is I want to address later. I want to address a certain bad habit in learning. Okay, let me show you this. Number three is, okay, how about this one? 5 to the power of x equals to 70. Okay, can I use this? So x equals log of 70. Can I ask you, Yoela, can I translate that exponents into logarithm that way? Hello? What, Yoela?
Hello?
Yes? So what's your answer?
Um, is it because it's 5 and not 10? Or does
Yeah,
it work with other things too?
yeah. So you cannot do that since the base is 5, not 10, right? So we cannot do this. We can only do this if the statement is 10 to the x power equals to 70. Therefore, x must be equals to log 70. Yes. But since the base is 5, we cannot do this. Wrong. Okay. So how do we find the x? Okay, for those who have already learned the base where that is not 10, I want you to follow this also, since I am introducing one of the property here. Okay, so since let's just pretend we don't know how to deal with this because we only being taught with 10 as the base. So the question now, how if we deal with 5 as the base, or 6 or 7? So since we know only 10 as the base, let's force 5 into a 10 to the power of k. Why? Because I want to replace 5 to become a number with 10 as its base. Of course, we cannot use this definition, right? 5 equals to 10. Of course not. 5 and 10 are different. So let's use an analogy or yeah, just like if. How if 5 equals to 10 to the power of k? So I can find actually the exact number of k to make this into 5, right? But I just don't know what is the k. Okay, let's just pretend it is 10 to the power of k. Therefore, if 5 equals to 10 to the power of k, I can replace the original statement here into 10 to the power of k to the power of x equals to 70, right? And then 10 to the power of kx equals to 70. Now we have situation with 10 as the base, right? So we can use the definition. Let me just use log both sides. So let me just use log. I will use the second definition. If I put log on the left, it's the same with log on the right. So log 10 to the power of kx, it will be kx itself. It will be log 70. Now I can find the x. The x will be equal to log 70 divided by k. Now we have problem. I want to find the x, but we have to find k first, right? We cannot find the x if we cannot find the k. How do we find the k? We go back to this. Since 5 equals 10 to the k power, Timothy, can you find what is the value of k?
What is that?
Can you get the
Five.
value of k?
The log 5.
Of course, log of 5. Because 10 to the power of k equals 5. Therefore, k will be equal to log 5, right? Therefore, I can know that k equals log 5, so I can continue to find my x. Log 70 divided by log 5. There you are. You can use your calculator. Log 70 divided by log 5, you get your x. We can solve the exponential or with base 5 with logarithm base 10. You get what I mean, right? So, oh yeah, uh, indeed, this is the condition that I use to enforce 5 to become 10, right? 5 equals 10 to the power of k. Based on definition, if 10 to the power of x equals to 5, let me use 10 to the power of 2 equals to 100. In the log 100 will be equals to 2, right? 10 to the power of a equals to b, then log, then a, wait, 10 to the power of a equals to b, then a will be equal to log b, right? That's why you need to memorize now how to translate from exponent to logarithm. The a, the exponent, will be equals to log of the b, right? Now we have 5 equals to 10 to the power of k. Therefore, k equals to the log of the 5. I hope you get the point here. So I use the definition of the orange box here to find the k. And after I find the k, I substitute the k into this one. Okay? Why? Now, I will go back to the bad habit of learning. I intentionally showing you this because you need to understand each of these steps to understand more about the properties later. Okay, I know that some of you may have already concluded, oh Mister, berarti yang pentingnya cuma ini doang dong. Look, 70 and 5. You lost the point here. Okay, so I want you to understand all of these steps. Why we doing this, and in the end, we can conclude why we can deal with any logarithm with different base, not just 10. This is the foundation. I want you to understand. Okay, let me just give you one example, one more, just to give you a grip of this one. So if I have 7 to the power of 2x equals to what? 1234. Okay. Again, we have situation that the base is not 10. So I will force that 7 must be equal to 10 to the power of k. Let's just use k. Okay, but I don't know what's k. So because I know that 7 equals to 10 to the power of k, I will substitute 7 by 10 to the k power to the power of 2x equals to 1234. Therefore, 10 to the power of 2xk, I will just multiply it, right? So in the end, I know that 2xk will be equals to log of 1234. So x will be equals to 2x will be equals to log, wait, sorry. X will be equals to log 1234 over 2k. And what is k? Again, return to this one. I know that 7 equals 10 to the k power. It means k equals log 7, right? So in the end, I will know that x will be equals to log 1034 over 2 times log 7. And then you can use your calculator and then you will find the exact value of x. Whenever you are uncertain, is that the correct answer? Of course you can check, right? Check back to the original one. Use the final answer. Is it true 7 to the power of 2 times x, 2 times the one that you have been found, equals to this? That's the way you're checking your answer. Okay. So in the end, actually, you can conclude this is a property that we will learn on Monday. Whenever you have look at the form 5 to the x power equals 70. Therefore, x equals log 70 divided by log 5. That's the conclusion, right? So let me just clear it. 6 to the x power equals to 125. In the end, when you follow the steps by steps with the previous method, you will learn that x will be equal to log 125 divided by log 6. 7 to the x power equals to 1 over 1 to 5. Therefore, x will be equals to log 1 over 1 to 5 divided by log 7. This is the properties that we learn on Monday, but this is just the introduction. I want you to understand how we can get into that. Yeah, so that's the three major parts that you have to learn about logarithm with 10 as its base. And I challenge you before we go to the properties, you need to master this. If you cannot master the definitions, you don't have to learn the properties. In the end, you will just failing. I bet you will fail, okay? Because it will be conflicting properties and then, oh, okay, why definition? Why look, it's just too much if you cannot get a grip now. That's why use the homework to practice. Now, the homework have two parts, right? The homework has two parts. So I want to, the first part, actually you are training to convert from exponent to logarithm. Actually, that is the objective for the first part. That's why you are given quite variations of problems so you can learn how to convert first. For example, this one. So never use calculator or any machines that just yeah, they really want you to be stupid actually, these machines. Watch Terminator. So don't be submit to the machines. Okay, keep your brain strained. Okay, now 4.35, for example, right? So use the definition of logarithm, right? We have 10 as its base. It means negative x equals log of 4.35. So you can use calculator. So the first part you can use calculator, of course. So x will be equals to negative log 4.35, and the value of this one, find it using calculator. That's okay, since we are learning about definition. You can use the calculator. That is part 1, section 1. Part 1, section 2, 3 to the x powers equals to 2. I know that you have learned in the end from the third part that x will be equals to log 2 divided by log 3. Yes, I get it, because that's the conclusion that we have. But I challenge you, at least one problem or two problems for you to practice yourself. Use this approach. If 3 equals 10 to the k power, like the one I did at the third examples. So in the end, I will convert this into 10 base first. 10k x equals to. Let me, based on my experience, if you have a grip in this, it's easier for you to learn the properties later. Okay, so I want you to practice to do this at least one, at least or twice, or maybe the whole thing. That's better. But of course, yeah, in the end, you measure yourself. Can you really understand this or not? Okay, so use this. So 10 to the power of kx equals to 2. So kx equals to what? Log 2, and then the k comes from here. It is log 3, and then so forth. Just like the examples I gave you. It is suggested. Again, I have no need to for you to practice a lot, right? So it's for your own benefit. Whether you understand it or not, it's not for me, right? It's for you. So again, see the homework as a media for you to practice. Yeah, yeah. And the second part, oh, sorry, one more thing. The second part, okay, the first part you can use calculator. The second part, never use calculator, because the second part you are practicing how to convert logarithm into exponential. So the opposite. The first part exponential to logarithm, the second part logarithm to exponential. Let me give you example. Later I will give, tomorrow we have no meeting. I will give you the video for this section. This is the example. Okay, and you have to find x. So convert this into the statement of exponential, which is x equals 3 square. So x equals 9. So don't use calculator, because all of the numbers on your homework has good numbers. Try to use this method. But I know that you don't get it now because I haven't teach you about this form. It will be provided tomorrow, but you can. If the answer is decimal, do we just round it? Do we have decimal? Oh, for the first part. The first part, yes, round it to the thousandth. Okay, the first part, round it to the thousandth. But for the second part, I believe all of the numbers are good. I mean, it's in rational numbers, so you don't have to use the calculator. And yeah, see the objective here. Again, these two parts is the foundation. Okay, I want you to really, before to next week on Monday, we are starting the properties. Therefore, on Monday, no question, you have to master the definition. Okay, that's the objective. Okay, so tomorrow, again, no meeting. I will provide you the video, but I think by reading the textbook only, you can understand the second part. So the video is just to assist you, okay? If you have no more question, then you can be dismissed.
Thank you, Mr. Thank you, Mr.
Welcome,
Thank you,
Thank you,
Mr.
welcome, see you.
Sir, I want to ask. So, log itu bukan simplest form, right? If misalnya jawaban akhirnya di log itu not the simplest form yet. Yeah.
It depends. Kita lagi ngomongin part apa nih?
Like part
Jadi
1.
part 1.
Jadi kalau misalnya nggak dapat kalkulator, jadi kalau jawabannya saya terakhir log 70 per log 5,
cari.
is that considered simplest already? Cari. Jadinya ke exact value, right?
Ya, karena nanti kamu harus ngecek. Jadi tujuannya adalah kamu sebetulnya kan ini masih definisi kan, belum properties. Jadi kamu cuma mau ngecek benar nggak sih jawaban kamu kalau kamu masukin lagi ke awal. Jadi sebetulnya jadi supaya kamu bisa ngecek, makanya nyari exact value-nya. Just for your apa istilahnya, untuk memuaskan kita juga bahwa benar nggak sih gitu loh. Benar nggak sih jawaban kita. Jadi ya, jadi cari aja pakai kalkulator into hundredth atau thousand lah, 3 decimal, 3 digit satu decimal. Ya.
Okay. Thank you, Mr.
How are you? Are you close enough with your grandmother?
Ini kan from my dad's side, right? So I'm not that close.
Oh.
So it's not as bad, but yeah, kaget aja.
Di Bandung atau di Jakarta atau di kota lain?
Harusnya itu kan dari Madiun, but she moves to Bandung. Tadinya tuh mau operasi, but keburu nggak ada. I think, yeah.
Jadi kalian ke Madiun?
Enggak, di Bandung. Kan the corpse, right? I think now you can't transport the corpse to Madiun. Kayak pindah kota, kudu burialnya kan cepat.
I see.
Jadi udah tutup peti and stuff. Ya.
Oke. Sekali lagi ya, accept my condolence and ya besok jadi santai aja. Kalau bisa usahain, kamu juga mungkin akan sibuk minggu-minggu ini. Sama jadi gini, Mr. Challenge kamu tetap kerjain terbaik sebisa kamu. Kalaupun akhirnya kamu butuh extension, Senin pagi kita harus ngobrol. Maksudnya pas pertemuan butuh waktu berapa lama. Cuman kalau bisa sih diusahain langsung bisa ya. Oke.
Ya, bisa kayaknya mah. Oke. Thank you, Mr. Martin.
Oke, welcome Karin.